Okay, this training obviously is about EV vehicles and emergencies, and do a little brief overview about lithium ion batteries. And this is obviously it's a pretty hot topic in the fire service currently, and this is the subject matter of Safety Stand Down 2023. That typically happens in June. Obviously, you guys are more than aware that in October, we typically send out this information. Inside of this Fire Rescue One training, you'll find some links to those websites, and obviously feel free to hit those links and go through that information. There's a ton of stuff out there by NFPA and UL and all the leading researchers as it comes to EV emergencies and lithium ion in particular. So obviously goes through that stuff as you can. All right, so some objectives we're going to talk about, kind of like the lithium ion battery technology itself. Again, brief overview. We're not scientists. Some safety concerns. We'll discuss fire involving the lithium ion battery vehicles operating at the MVAs, some safety concerns, extinguishing, operating in the entrapment, review some FD&Y procedures, and then we'll look at, again, the NFPA links that's on the MDT, and I'll be referencing that multiple times throughout this training. So again, those links are on all the MDTs and all the apparatus. If you've not looked at those, please take some time. So just a couple stats. 2011, approximately 16,000 EV hybrid vehicles were sold. 2020, 1.7 million. They say by 2030, they're estimating that 28% of the vehicles on the road will be EV or hybrid, and then by 2040, 58%. So I guess at the end of the day, right, this technology is not going away. And currently you're seeing there is a ton of information out there about how to handle these emergencies. And again, we'll talk about some of those things as we go on through this program. But just know that this stuff is kind of changing and evolving every day. So again, the training division, our battalions, operations chief, we're all working on trying to get the best information out to you guys as soon as we get it. And I know that Westchester, we just formed a committee and talked about policies, procedures, training, and that kind of stuff, almost countywide, not just here at Westchester. Let's talk a little bit about the technology. Obviously, it's comprised of a lithium compound, and that is the negative electrode. And then typically graphite is used as the positive electrode. Now, electrolyte is typically lithium salt that's dissolved in some kind of organic solvent. The capacity of the battery is measured in kilowatt hours. So a hybrid vehicle will have a battery capacity of approximately 16 kilowatt hours, and EV batteries can be anywhere between 60 and 100 kilowatt hours. And a conventional car battery, obviously, we know is 12 volts. EVs, they're talking, some can be up to 300 and 400 volts. So again, this stuff is extremely dangerous, right, to be operating around, especially in an emergency scene. So components of the battery, and I got a couple of examples of what these kind of batteries look like in a vehicle. Again, they're comprised of individual cells. These cells are assembled into modules, the modules into battery packs, and then the batteries are packaged into a case, and that case is designed to protect that battery from being damaged, right? So if you look, I got a couple. One is the Tesla, that's the top one there. Basically, the whole floor pan is the battery, and that casing is what you're seeing, that metal around it. Then I got a picture of the Bolt, I should say Bolt, B-O-L-T, not V-O-L-T, from Chevy. And then The one on the right is the Rivian. And then again, you'll see, I know I see the Rivian in Westchester quite a bit. There's a few of them driving around the township. This is kind of a picture of the battery pack. So the battery pack, again, is comprised of like thousands of small cylinder batteries, about the size of a AA battery, maybe just a little bit bigger, packaged into 16 modules that are typically found, again, on the floor pan of a vehicle that we see driving around today. All right, so let's talk about some safety concerns, right? So three big ones. First is electric shock. Again, electric shock from a high voltage side of the system. Human body, obviously, we know is an electrical conductor. If it contacts an energized source of electricity, or current, and again, the current will flow through it. The body's resistance, again, that's the ability to reduce the electric current, varies from person to person. And according to whether the skin is wet or dry, and among other things. Maximum voltage considered safe for humans is about 50 to 60 volts DC. And that's direct current, or 30 volts AC, alternating current. Again, the high voltage side of an EV operates well above these thresholds. Again, we talked about earlier, 3 to 400 volts or more. And again, that creates a very risky environment for us to be operating on and around these vehicles. The manufacturers, right, they have built some safety factors into this thing, right? So they made this thing so if this thing was involved in some kind of accident, that it'll shut off that high voltage side. Now, that's how the engineers have designed it. And again, we kind of operate in a realm, right, of things that don't go well. So we have to have the understanding of maybe that system is not shut down and try to operate around it as safely as we can. Talk about a little bit about thermal runaway. I know you guys have probably heard this term. Thermal runaway is a chemical process that produces its own heat. Again, exothermic reaction. This heat increases the rate of the reaction, which further increases the temperature, and that escalates the process. Thermal runaway can spread from one battery cell to another, and again, it's kind of like a domino effect. The originating cause of the thermal runaway is generally a short circuiting inside of the battery cell and resulting in increase in the cell's internal temperature. That short circuit of the lithium-ion battery cell can result from defects introduced during manufacturing, or more likely, some kind of accident, right, where that battery is impacted in some way. And we've had some local examples. I know on the east side, I think it was Union Township or somewhere around there, they had an EV vehicle fire and the vehicle was traveling at a high rate of speed, was involved in an accident. That battery was damaged and it caused that thing to catch on fire. Then again, we'll talk a little bit about stranded energy. And this is, again, another extreme danger of these things is that even if the fire is put out or whatever, there's still energy inside of that battery cell, right? So the high voltage battery is damaged, energy remains inside any of those undamaged batteries. And again, right now, again, currently, I think some manufacturers are trying to determine ways where they can get rid of that stranded energy, but we do not, I don't know of any of them that are in our area. So again, there's no real good policy or procedure to do that. So that stranded energy can cause high voltage batteries to reignite multiple times. Again, we've seen this. I know California had one where it just kept reigniting. After the fireman put it out, put it on a flatbed, it started on fire again, took it to the salvage yard, and days later, again, it started on fire again, it reignited. And again, that's all about that stranded energy that's left inside that battery. So some dangers of thermal runaway, again, cause fire and explosion, venting of toxic flammable vapors, combustion of the vapors, ejected from a flammable electrolyte solvent, overpressurization, and then rupture the cell's casing and releases projectiles. So it's almost like an explosion if that case, excuse me, is not damaged in itself, and energy has nowhere to go, it will eventually make that casing explode. So some of the big things for us, obviously, is having PPE on. I think, we typically do a really good job on vehicle fires wearing a PPE, especially when we're really close to an active fire. But once that fire's out and it may be smoldering, sometimes we may get a little bit lackadaisical on that and take our mask off and continue with that overhaul process. It's imperative, and again, you'll hear me say this multiple times again, that you keep that PPE on. Battalions on the scene, make sure the guys are wearing and breathing air as they get closer to that incident. I mean, those flammable gases could be hydrogen, ethylene, ethane, propane. Again, a lot of dangerous things that are harmful to us. So again, make sure that we have all our PPE on and we're using it appropriately. So again, we'll talk about again the federal government, NFPA. A lot of these people are working together to kind of standardize some of these, the way these emergency guidebooks look like. When EVs first came out, there really wasn't a centralized place that you could go, right, to find this. And there really wasn't any kind of oversight from some kind of entity to telling these manufacturers, like, hey, every cut point should be here, like all these just very standard things. So you'll see as manufacturers change that where we cut, where we de-energize, how we de-energize, all those things changes from model to model. Even within a certain manufacturer, they can change. So I'll reference this again. This is kind of like NFPA's emergency response guide. You guys again have that icon on your MDTs. If you're not familiar with that, go out into this training, open that thing up and just kind of work your way through it. It's pretty intuitive to use, but again, the first time you use it shouldn't be, at an emergency scene. So go through that stuff to make sure everybody understands how that works. So we'll talk a little bit about operating at an MVA involving an EV vehicle. And again, what should we be doing first? This is straight from like NIST and other people that have come up with this. So basically identify, immobilize, and disable. So the first thing is kind of identify that we have to understand, are we at an EV or a hybrid vehicle? Again, sometimes this is really easy, right? We all know what a Tesla looks like. We all know what certain of these vehicles look like. They're pretty easy to identify, but others may not be, especially the hybrid vehicles. Honda Accord is, a lot of these manufacturers have hybrid vehicles, and they're becoming more and more popular. So looking at badging will kind of help identify those things. Again, immobilization of these vehicles is imperative. So we must do that. And again, disabling could be, it's not as easy, right, as just taking the ignition, turning it off, placing the car in park. There's going to be other steps that you have to do. I know that Tesla doesn't have they only have a key fob. It's almost like a credit card, right? That typically that owners carry in their wallet. So identifying those things, taking those key fobs away from bystanders so we can take control of that vehicle is pretty important for us. Talk about some badging. Again, I got a couple of pictures here. Sometimes you'll see that blue, right? That blue color kind of indicates EV or hybrid badging. Obviously, we talked about the knowledge of the EVs, and sometimes even VIN numbers can give some identification that this is a hybrid vehicle or an EV. Obviously, the vehicle is involved in a rollover, a major collision, or it's on fire. Sometimes that may be very difficult for us to capture. So doing 360s, right? Trying to gather as much information as you can before you start operations is pretty important in this thing. And remember, just kind of I think everybody may know this, but all EV vehicles do not have exhaust pipes on them. So if you don't see that, that's a pretty good indication that it's going to be an electric vehicle. Immobilize the car, chalking the tires, right, is going to be really important. EV vehicles, right, they do not have combustion motors, so it's going to be really difficult for you to understand if that vehicle can is running or not running, or is on or off. So chalking those tires right away is really important. Placing the car in park. Obviously, the picture up there with the P is pretty self-explanatory. The start-stop button, pretty self-explanatory. But again, some of these vehicles don't have those things. So understand how need to immobilize that vehicle is important. And again, that emergency resource guide from NFPA will give you step-by-step on how to immobilize that car and shut it off. All right, so disable. Again, this says it should be done, and it typically occurs only on major accidents. So EV vehicles are designed, if they are in a major accident where airbags are deployed, or maybe the seatbelt tensioners are activated, that it'll shut off that high voltage side of the vehicle. And again, it should, right? A lot of these things rely on relays, and relays can fail, right? So let's never assume a car is de-energized until we have taken the proper steps to do so. Again, I referenced the emergency guidebook and there's procedures. It's an invaluable tool. Remove that key fob. Sometimes, again, that could be a credit card. Capturing that and taking hold of that, it's almost like lockout, tag out. Make sure one of our personnel has that. And some of them say that it should be at least 16 feet away from a vehicle before you can actually disable that vehicle. Talks about cutting and disconnecting 12-volt batteries. So all these vehicles, EV vehicles run, they have a 12-volt side, so a low voltage side and a high voltage side. Typically that low voltage side will run some of the auxiliary components of the vehicle. It'll also run those relays to kind of shut that system off. So by disabling that, by cutting that, then you can isolate the high voltage side. Okay. Remember that once you do that, if we do not have access to that vehicle, so let's say it's maybe a minor accident, there's somebody in there, or you may have to get in there in the future. Once you make that cut, you're not getting in that vehicle. Okay. So if it's a minor accident and you cut that, then all bets are off, right? You're going to have to either break the window or force that door to get inside that vehicle. So just plan ahead, I guess, is the moral of that story. SAE, Society of Automotive Engineers, talks about a shutdown process. It says automatic shutdown of high voltage system based on the detection of a prescribed level of vehicle impact. So again, was the airbags deployed? Seatbelt tensioners went off? Those kind of things will allow that switching of the ignition and that power button in the off position. Again, that should happen. So let's never assume that. Also talks about cutting or disabling the negative and positive 12-volt battery cables to disable the 12-volt system, while also cutting or disabling the DC to DC converter 12-volt output cables will also shut down that system. The last way of talking about is disabling that vehicle is removing the manual disconnect. If I go back, to the picture of, all right, so on the bottom picture, that T battery, that the one from the Chevy Bolt, just where that T starts, you'll see like an orange circular right there. That's the manual disconnect. So there's an access panel on the floor of the Bolt that you can access, kind of twist that and pull it out, and that's the manual disconnect to shut down that high voltage system. Again, that is not recommended that we do that. That's like worst case scenario, right? That we'd have to go that route. And again, you'd have to reference that emergency guidebook to understand where that is and how to access that those panels. So let's talk a little bit about some safety concerns. Obviously, the big one is electric shock. Again, we're talking some of these are get up to 800 volts, extremely high temperatures. Again, high temperatures in a very short span of time. sometimes up to 2,000 to 3,000 degrees Fahrenheit, or what some of these are burning at. We talked about some toxic fumes, lithium burns, toxic runoff is a concern, right? So this is potentially going to be a hazmat scene if we have to dump the amount of water that we're going to have to dump on this thing and where that runoff is going. And again, reignition. It says right now I put 24 hours, but it could be days afterwards. Again, talking about that stranded energy still inside of that battery cell that could reignite that. So electric shock, obviously never cut into the high voltage side of the system. The standard now in the emergency guidebook is anything that is orange is going to be high voltage. So if you access some of these vehicles, those panels, you'll see orange cabling. Again, that is the high voltage side. We do not cut that, right? So we got to talk about, and we'll talk about this in the entrapment, like where are those lines running? Like you just can't take your cutters and start randomly cutting areas on these vehicles. We have to be very cognizant of where that stuff is prior to putting the tools to those cars. Again, high temperatures. We talked about the venting and the off-gassing. We talked about the pressurization of these things that can cause explosions. So approaching these in a safe manner. Again, doing 360, doing some reconnaissance prior to just running up to that vehicle is really important when we talk about operating around these vehicles. So EV fires, again, this stuff is changing every day. You can read a lot of the stuff is coming from overseas. They talk about using fire blankets, talk about using fire extinguishers. There was a brief moment in time where they talked about using almost like a piercing device, to pierce these battery housing to put water directly onto the batteries. You know, all this stuff again is just, it's constantly changing. I can't overstate that enough. We have to always be studying and reading up on this stuff. A lot of this stuff has come from, again, NFPA, NTSB, NIST, USFA. All these entities are trying to work together to come up with best practices. So what is the right extinguishing agent, right? Again, water is the most effective agent that we have. It's just going to take a lot of it. You can read about foam and dry chemical and CO2. All this stuff is shown to be somewhat effective, but again, at the end of the day, it's just copious amounts of water is going to have to be applied. We're going to talk about some firefighter operations, some byproducts of combustion, and again, that electric shock potential to us. I just put this in here again. This is from the resource guide. Again, talks about just some general safety principles, our PPE, and then extinguishing agents and what can be used. And again, this is not from NFPA. I'm sorry. This is from NTSB. So fire operations. If the fire is contained just to the cabin or maybe even the trunk of an EV vehicle, we can just use standard tactics, right? Conventional tactics. What we're really going to be talking about is if it actually involves the battery itself. Again, firefighters must avoid contact with any orange cabling and components that have high voltage warning labels on them. If the fires burn warning labels or render them otherwise illegible, firefighters should not touch any electric drive or drive system component, right? Let's use due regard when it comes to any of this stuff. Let's be as safe as possible. Firefighters should never try to attempt to breach the high voltage battery or the casing for any reason. So again, we talked about the stranded energy and the thermal runaway. When you pierce that battery, you can create that thermal runaway just by doing that simple act. Fires and engine compartments. fire in just a cabin is just conventional tactics. If it's actually involved that battery, then we may have to employ different tactics. Again, it's not really different tactics. It's going to be the same, right? We're just going to flow a lot of water on that. The key to that is trying to get the water into that battery, right? Where that heat source is being produced. If it's in the battery compartment and you're flowing it over the hood of the car, maybe that's where you see the flames, then we'll never extinguish that fire, right? We got to try to get into that battery compartment. Again, remember, this is going to take thousands of gallons. You know, you can read 2, 3, 5, 10,000 gallons of water sometimes to put these fires out. So, you know, establishing water sources is going to be imperative. And we'll talk about some other things, maybe just letting it burn if there's no exposure hazard, right? I know that's something that we don't like to think about or something we typically do not do, but that may be a tactic we must employ when we're dealing with these things. Yeah, we talked about, you know, obviously don't cut or pierce any part of the vehicle and protect any exposures. And sometimes the best practice is just to let it burn. That may be obviously the quickest way for it to expel all that energy. So this is a picture of a hybrid vehicle. And this is kind of why we do not spike the hood. We do this technique all the time to kind of get the fire and engine compartment. Obviously, EV vehicles themselves, true EV does not have an engine compartment, but hybrids do, right? They have a combustion side and an electric side. So if you used your halogen or anything else to try to pierce that hood and you hit that orange cabling, right, that is bad news. That's a high voltage side of that vehicle. So that's why we do not do that on EV or hybrid vehicle fires. So some considerations, command should consider time of extinguishment. Again, this could be a long operation. Firefighters may need multiple bottles, right? So almost like a structure fire, we may need multiple resources there. Safety officers, and again, we talked about additional resources, especially for operating on the highway and how much water we're going to need. I know our Chief Hannafin is working with the with ODOT and the highway, trying to get access to hydrants on the highway to make those accessible for this very reason. We'll be applying water in one location for an extended period of time before moving the hose stream. So again, I think a lot of times in conventional fires in passenger vehicles, right, you may put, you know, 100 gallons, 50 to 100 gallons in one area, and you're moving on, right? This is going to take a lot of water. We got access for hot spot. You have to look for hot spots, and it could be difficult, right? So one thing that we have that we should be using is that thermal imaging camera. Get that thing out and figure out where that heat is coming from so we can direct that stream in the best possible location. So again, this is kind of stuff that you may have seen. And again, it may be changing, and it does change all the time. There's a big contingent out there that, again, if it's not affecting exposures or it's not affecting, if there's no life hazard, then just let it burn. There's stuff out there about foams and effective, ineffective, Class D extinguishers. There's this pancake nozzle where kind of they shove it underneath the bottom of the car. I can't remember what manufacturer had, but I actually saw one that was like a pancake that actually pierced the bottom of that battery pan. Again, that is bad. It's a bad idea. Fire blankets, especially overseas, they're experimenting with these things all the time. If they're effective, if they're not effective. And again, we talked about piercing nozzles. Again, that is a big time no-no. We do not use piercing nozzles when we talk about any kind of EV or hybrid vehicle fire. But again, I think at the end of the day, right now as it stands, it's just a lot of water is what it's going to take to extinguish it. Overhaul. So once it's out, right? So once we get it out, especially when we're talking about a vehicle fire, like inside of a garage in a house, right? We get the initial extinguishment. We need to utilize some kind of winching system, either be engine 71. Hopefully they're there, right? We can make connection and get that vehicle out of that garage. So if and when it does reignite, right, we're not burning a house down in the process. So once it's out, a lot of times, again, I alluded to this earlier, sometimes we take our mask off, right? Especially if it's hot outside and we start doing our overhaul procedure. Again, this thing can still be off-gassing. So we must remain in our PPE. We have to be diligent about this. Battalions, company officers, and again, firefighters themselves, if you see one of your own taking their mask off, right? If they need rehab, take it, but get away from the scene before you do so. We talked about using the tick. We need to start thinking about using air monitoring. Again, I know that's something that is completely outside our current policies, procedures, especially on vehicle fires. But this could very well turn into a hazmat scene, especially for runoff. You're reading more and more about that. So consider air monitoring sooner than later. We have that. Again, we talked about the possibility of contacting the manufacturer. There are emergency contact numbers on all those emergency guidebooks. So if you have to contact them, a lot of times they'll have a 24-hour resource that's available to first responders. But again, that icon will give us a lot of the information that we need, at least in the initial parts of the operation, to operate safely. And California's dealt with this quite a bit. I don't know if I've read it in other places around the country, but I'm sure it's happened where, again, kind of like the secondary first responders, so our tow companies, they come, they take this car, and at some point in time, again, it's going to reignite. I know down at Cohen, in Sharonville, right next to us, guy was dropping off some scrap. Inside of that scrap, he had basically the whole battery, whole floor pan of an EV vehicle. He dropped it off and left. The guy was moving that pile of debris from one place to another. That battery reignited. Sharonville Fire Department was called. They put a bunch of water on it, and then came up with the idea of filling a small container full of water and then submerging that battery in there. Myself and Battalion Chief Tully went down there. I know it was days later. It may have been a week or so later to look at it, and it was still bubbling. So it was still off-gassing inside of that. And this was a long time later. So again, this stuff is always changing. You're reading about covering them with sand. Again, all tow companies and these junkyards that are accepting these things have to come up with their own policies and procedures, again, how to deal with this new technology. Talk a little bit about extrication. Again, immobilization and disabling the vehicle is critical. Okay, it's not just as easy as opening the hood and cutting the battery, right? PPE, do we need to have SCBAs on during an extrication? Again, if you hear any kind of hissing or popping or see any kind of light smoke, then it is critical that you have that PPE on. So instead of having two of our rescue companies and another one, you may have to have 2 or 3 or 4 extra, right? Just for manpower purposes alone, to try to cut some of these vehicles, just because of the stuff and the extra gear that we have to have on. Ventilation may be needed. Again, some kind of PP fan blowing away from for our responders. Charged hose line must be in place. Again, I think this is a practice that we do already. I think sometimes we feel like we don't really know the reason for it, where now it's imperative that we have that hose line charged and ready to go. Again, avoid contact with any kind of high voltage cabling or components. And we have to talk about, again, some of these techniques that we've been doing, right? So we do like a modified dash roll, right? Where we're cutting into the A post and that A pillar. Right? So it's going to be critical that we have somebody, almost like a resource individual that's kind of dedicated to the computer to make sure that we understand where we can cut and where we can't cut. So we talk about tunneling, right? There's also, if you go on the crash course, you make access through the floor pan. Again, those things are not going to be accessible to us in an EV vehicle extrication. So we're going to come up with different solutions to get these victims out of these vehicles. I just put this slide in here. If you look at the pink areas, or pink or red, whatever color you're seeing there, those are the no cut zones, right? So some it's in the B, right? So if you think about doing a rip and blitz, right? In this scenario, right? You cannot do a rip and blitz on that Model 3 Tesla just because of that, on that B pillar, the high voltage stuff that's located there, right? So we just, again, we have to be creative and coming up with different solutions on how to extricate these patients from these vehicles. I kind of want to briefly discuss the Rivian delivery vehicle. Obviously, we see these all over Westchester. They're housed right there at the distribution center, Amazon's distribution center on Allen Road. And that's where they get all their charging, all that stuff's done. There'll be some more details to follow, more trains coming out on those charging stations. But basically that vehicle is manufactured by Rivian. And again, I talked about that Rivian truck. I know there's at least 2 or 3 or 4 running around Westchester. I see them quite often, right? It's the same manufacturer. I've taken a couple screenshots of the emergency guide for NFPA as it talks about this particular vehicle, right? So where we can make the access cuts, where we don't cut, all those things are located on and in that resource guide. This is kind of what that icon looks like on a desktop of the MDTs. So make sure, again, after this training, go out there, take the crew out there, open that up, and kind of maneuver through that website. So again, you kind of become familiar with it. This PowerPoint will be housed in Fire Rescue One also, so you can utilize that link, that hyperlink there to kind of get to that guide also. Again, you can hit these hyperlinks also. FDNY, again, they're probably one of the fire departments that's producing some of the most current information. And that's really just because they deal with a lot of these fires. And a lot of them in like these small mobility, they call devices. So small scooters and that kind of thing, you know, in that urban area that is super condensed population. These people are taking taking their scooters into these high rises, charging them, and they've again been responsible for multiple deaths in New York in 2022 and in 2023. So I know that they're producing safety and training tips all the time about how to deal with some of these fires. So some of the takeaways I want you guys to think about this kind of stuff is, again, scene size up. We do a scene size up on vehicle fires, but we just need to do a little more in-depth one, right? Take some more time, do that 360, understand what you're getting into, right? We don't want to get so deep into the event before we realize, right, we're dealing with an EV vehicle. Remember to identify, stabilize, and disable. If possible, before disabling the 12-volt system, open up the entire vehicle. And again, I'm talking about minor accidents, right? Before we send firemen in there to make that cut, that we open up the vehicle prior to, because if we don't, then it's just going to be a lot more difficult to access that compartment. Never cut the high voltage side. Again, orange cabling, and that is standard across all manufacturers. So if you see orange, that's no cut. Again, we use that resource guide. It'll show you where that stuff is located and how it's run throughout the vehicle. When dealing with EV fires, again, think about extended operation. So a lot of times, if we just have a vehicle fire like on a residential street or a residential driveway, you know, you're just going to get one engine company. Company officer, when you arrive, if you believe that this is an EV vehicle fire, then call for additional resources right away, because you're going to need them. This is not going to be a 250 to 500 gallon fire. It's going to be thousands and thousands of gallons and hours, right, to take care of that situation. Talked about, you know, some of the stuff we're doing on highway, dealing with ODOT, trying to get some access to hydrants. Think about tankers, right? Get those coming our way. We have some in a general vicinity of us, but it's going to take them a little while to get to us and get that operation set up. So call for those resources early. Again, big thing that we have our PPE on, right? Make sure we're breathing air when we're operating around these EV vehicles that are damaged. So if you hear off gassing, if you see vapors, if you hear popping or cracking, right? Make sure our PPE is on and we're breathing air. I say eventually we're probably going to start talking about bringing a hazmat vehicle over for some more advanced air monitoring, but everybody carries multi-gas on their rigs, so we can start with that. And again, when we teach extrication training, we talk about peel and peak right on those pillars before we start making those cuts. And again, right at that conventional vehicles, we're talking about like airbag actuators, right? So we don't cut those. Those can cause fireman injuries. But this is even more important, right? That we have to peel back this plastic and take a look before we do any cutting. Seatbelt tensioners, again, we don't really concern ourselves that much with them in conventional vehicles. But again, basically, these are little pyrotechnic things that go off, right? So make sure we're cognizant of where these things are located. Before we start cutting, open that emergency response guidebook. Company officers, that may be you, or maybe you want to assign somebody to that role. Again, that's why we need some additional resources to that, so we make sure we're operating as safe as we can. So if you guys have any questions, obviously feel free to reach out. I'm going to embed some links into this Fire Rescue One program that you guys can access at any time. I mean, there's podcasts. NFPA has a training that's a part of the fire safety stand down. It's a 4-hour free course that goes through a lot of this stuff. Feel free to access this stuff. Be on the lookout from the training division about stuff coming out all the time as this technology changes and it has policies and procedures change. Part of that committee, obviously, Assistant Chief Hannafin and Battalion Chief Tully are kind of heading that. So any questions or comments or anything that you come across that you find interesting, feel free to send that their way. Again, hope you guys have a great rest of your day. Any questions or comments, please feel free to get with me. Have a great rest of your day.